Hey Algebras, wondering how you're doing with all of this homework and video learning. I hope you're doing a good job and trying your hardest to learn these new things. Okay, so here we are. The key for homework 12 is each ordered pair a solution to the inequality. Remember how we defined solution. That is going to be a value for the variable that makes the equation true. So that little shorthand, those three words, are going to remind you what a solution is. And when we talk about the word solution, that's our job in algebra. That's what it's all about. We're working hard to find all of those solutions, the values for the variable that make the equation true. Okay, so what I'm going to do is I'm going to test to see if each of these work in this inequality. Here's my x and here's my y. So I'm going to take -3 times that x value plus that y value, and I'm going to see, is it smaller than 9? So your choice is to go ahead and do your math. And I know that -14 is definitely less than 9. If you are a person who needs the support of the calculator, it's okay. Just make sure you know how to use that tool. So -3 times that x value plus that y value, and you're going to see, is that smaller than 9? Yes, it is, because remember, the alligator eats the larger value. So yes, this one is true. So now we're going to test my second one, because I want to make sure that I complete all parts of the question. So there's for 5-1. Now we're going to put this x and this y. So -3 times this value for x plus this value for y is smaller than or equal to 9. So I have positive 18 plus 3. I have 21. And I can ask myself, is 21 smaller than 9? No, it's not. And again, you can go ahead and do this math. -3 times -6 plus that 3. And you can see 21, and 21 is not smaller than 9. So therefore, your answer is, remember, you're answering this question, is it a solution? Yes, this one is, and no, this one is not. All right, so this testing and finding solutions is real important in this unit because it tells us where we're shading, where we're coloring, where are all of our answers. And that's our job, that's why we care. Okay, 8 times -4 plus 4 times -6. We're going to see if that's bigger than -12. So -32 plus -24, is that bigger than -12? That's going to be -56. Is that bigger than -12? And that is a big no. And again, use your calculator if you feel like you need it. So 8 times -4 plus 4 times -6. -56, smaller. That's to the left. That's more negatives. Think about debt. If you had a debt of $56, is that better or worse than a debt of -12? All right, now I'm going to do 0, 0, and you're going to find 0, 0 becomes our favorite point to choose when we're substituting in, because our zero product property makes the math so much easier. Anything times 0, our zero product property. Anything times 0 is 0. So suddenly this math becomes very easy. Is 0 bigger than 12? Yes. So this one is a solution. We like 0, 0, and you're going to find we use it again and again and again. All right, here's our directions. Solve and graph the inequality. Then identify 2 points that are solutions to the inequality. Use your calculator to check your answers when possible. Okay, So an inequality means I have an infinite field of solutions. I just need to know where that field is on the coordinate plane. So I have x, we're going to subtract 6 from each side, and I have x is bigger than 4. This looks like a Vux to me. So 1, 2, 3, 4. I have no equal to, which means this is going to be a dotted line. It's a Vux, a vertical line with an undefined slope and an x only, means that every ordered pair that sits on this line starts with a 4 in the x position. My output can be anything. That's why it's a vertical line. All the values of x are greater than 4. So if I want to, I can look at and recognize that any x value smaller than is not going to make this true. So I can go ahead and color in this side. And I want you to pick any two solutions that are going to work. I can go ahead and pick this solution. This has an x value of over 6, up 0. I can pick this solution, which has a value of over 5 and down 1, 2, 3. Now, meanwhile, your solutions could be anything. So whatever you pick inside of that colored in, shaded in field works as a solution. And you can substitute these x values in and get a true inequality. All right, so we've just had the Vux. I'm pretty sure what's going to be next is going to be a Hoi, and I know because I have just a Y. So I'll go ahead and divide by -8. And don't forget to flip the sign because you divided by a negative. So y is going to be smaller than or equal to -3. 24 divided by 8 is 3. So we'll go ahead and go down to -3. 1, 2, 3. And I know it's going to be a horizontal line with a slope of 0. And I'm going to come back up here. Oh, look, it's allowed to be equal to it. So because it can be equal to it, instead of a dotted line, I'm going to draw a solid line. All my values of y are smaller than. So when I look at anything that's below here, it's going to have a value that's smaller than. So every single point inside this shaded area is a solution. And I can pick anything that I want. So for example, I could pick, I don't know, how about this point? So I'm going to say over 1, 2, 3, 4, and down 2 is a possible solution. Any point, I'm going to pick this one. How about over a -1, 2, 3, 4, 5, 6, 7, down 1, 2, 3, 4. Over -7, down 4. Again, these answers could be anything that's inside of our shaded area. All right, so there's our Vux. Here's our Hoi. Now we're going to have our linear equation. So our linear equation, it's already in slope-intercept form. Y is equal to mx plus b. This b is our start, so we're going to start at +2, counting up from 0, 1, 2. Here's our slope, which is our rate of change, and it's negative, so that means I'm going to go down 1, 2, 3, 4, 5, and over 1, 2, 3. It's not allowed to be equal to it, so what kind of line am I going to draw? A dotted line, because it's not allowed to be equal to it. Okay, so here's where the test point comes into play. These two were easy for me to shade because I knew smaller or bigger, but I'm not taking my chances with a line, especially with a negative slope. Sometimes I don't guess right. So what I'm going to do is use 0, 0 as a test point. Is 0 bigger than negative 5/3 times 0 plus 2. Again, our zero product property we talked about up here is awesome because look, that just cancels that out. So is 0 bigger than 2? No. Which means that all of my answers are on the side of this graph that does not have my test point. So all of my answers are on the opposite side. Keep in mind, this line is dotted, so none of my answers are on the line either. So when I go to pick my 2 points, I'm going to go ahead and pick 2 points that are on the axis. Again, you can pick whatever you want. So here I did over 0, up 1, 2, 3, 4, 5, 6, 7. And my other point that I picked over 1, 2, 3, 4, and up 0. You can pick whatever points you want as long as they're on this side of the line and not on it. Alright, let's take a look at this one. Slope-intercept form again. So it's an easy graph for me to do. We're going to go ahead and go down to negative 3. 1, 2, 3. And my slope is 1/2. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. It's not allowed to be equal to it. So what kind of line am I going to have? You got it. It's going to be a dotted line. I'm going to go ahead and again use 0, 0 as a test point. 0 in for y, 0 in for x. Is 0 smaller than negative 3? No, 0 is not smaller than negative 3. So no, I'm not going to color where my test point is. I'm going to color on the opposite side of the line. That means all my solutions are down here. So when I go to pick 2 of them, it doesn't matter where I pick. How about here? How about here? So whatever these XY ordered pairs are, they're 2 of an infinite number of choices I could have made. 1, 2, 3, 4, 5, 6, 7, 8, 9. Over 9 down 1. 1, 2, 3 over negative 3 and down 8. All right, our next line, not in slope-intercept form. So we're going to go ahead and solve for y. Y is equal to, y is bigger than negative 3x plus 1. I subtracted 3x from each side. So here's my slope, and there's my intercept. A intercept of positive 1, and a slope of negative 1, 2, 3 over 1, negative 1, 2, 3 over 1, negative 1, 2, 3 over 1. Is it allowed to be equal to it? No. I don't see that line, which means I don't draw a line. You only draw the line if you see the line. Otherwise, you have a dotted line. When I pick 0, 0, it's not on the line. It's pretty close. And keep in mind, if this line went through 0, 0, you couldn't use that as a test point. You would have to choose something else. All right, let's test it. Is 0 bigger than negative 3 times 0 plus 1? We choose 0 because that's an easy cross out. So is 0 bigger than positive 1? Nope. That's not true. So what we're going to do is color the other side of the line all the way out here. When I pick my solutions, I'm picking any 2 points. So we'll keep these ones simple. How about these easy ones? How about over 2 up 0, over 3 up 0? And when it says here to use your calculator to check those answers, if I put 2 and 3 into this equation, I'm going to get a true number sentence. It will be bigger than 1 each time. All right, let's go ahead and write this in slope-intercept form. I'm going to go ahead and add x to each side because remember, I always want to solve for y. When I solve for y, it lets me see two very important parts of graphing: my intercept, which is where I start, and my slope, which is my rate of change. All right, so for this one, I'm going to start at +3. That's going to be my intercept. I don't see a coefficient here, which means it's 1. So it's going to rise 1, run 1, rise 1, run 1. So that's our parent function's slope. We have a different intercept this time. I see a line, which means I draw a line. See a line, draw a line, which means that my solutions can sit on this line. All of these other dotted lines, that is a boundary, but it does not include any solutions. All right, again, I'm going to choose 0, 0. So when I plug in, is 0 smaller than or equal to 0 plus 3? Is 0 smaller than or equal to 3? And yes, that's true, which means all of my solutions are on this side. I think I have to say goodbye to my blue pen. All right, so when I choose 2 points that are solutions, again, you can choose whatever 2 points you want. I went easy again. Over 0, down 1, over 0, down 2. And if I plugged both of those in, we're going to see that, -1 minus 0, yep, that's smaller than 3. -2 minus 0, yes, that's smaller than 3. All right, let's go on to the next page. So for our next page, our equations are getting a little bit more complicated. So I'm going to, again, solve for y, which means I'm going to add 10x to each side. So 5y is greater than 10x minus 5. Divide by 5, divide by 5, divide by 5. So my y is bigger than 2x minus 1. Now notice I never divided by a negative, so my sign stays the same. There's no sign flipping in this scenario. It's still going to be true because I added and then I divided by a positive, so I'm good to go. -1 is my intercept, my slope, rise 2, run 1, rise 2, run 1, no line, which means no line. If you don't see a line, you're not drawing a line, you're dotting. Let's go ahead and get that test point. Let's try to test 0, 0. Is 0 bigger than 2 times 0 minus 1? Is 0 bigger than -1? Yes, that's true, which means I color on this side of the line. Whenever I'm picking solutions, go ahead and pick anything you want. And again, I'm going to choose really easy solutions. I'm going to say over 0 up 1 and over 0 up 2. We could all have different solutions here. I bet you none of us match. As long as you picked a point that's in this field, you're good to go. All right, solve for y. I'm going to subtract 2x, subtract 2x. So then I'm going to have -6y is smaller than or equal to -2x plus 12. I'm going to divide by -6, which is going to switch my sign. So positive y is greater than or equal to 1/3 x minus 2. So here's my y-intercept. A slope of positive 1/3 is rise 1, run 1, 2, 3. I see a line, so I'm going to draw a line. I'll pick my test point, and I'll say, hey, is 0 greater than or equal to 1/3 times 0 minus 2? Is 0 greater than -2? Yes, it's true, which means I'm going to shade on this side of the line. Let's do number 11. I'm going to go ahead and solve for y. So I'm going to add 3x to each side. Negative 2y is greater than or equal to 8 and 3x are not like terms. So I have to keep them separate. My 3x is positive and my 8 is negative. Divide by -2, switch my sign. Divide by -2, divide by -2. My y is going to be smaller than or equal to -3/2 x plus 4. -8 divided by -2 is positive 4. So I'll come up here to positive 4. 1, 2, 3, 4. And my slope is down 3. 1, 2, 3 over 2 in the positive direction. Down 3, 1, 2, 3 over 2, 1, 2 in the positive direction. So you notice my negative slope decreases from left to right and goes down. All right, I see a line, so I'm going to draw a line. So we'll go ahead and pick our test point. I love 0, 0 because the math is easy. We love it when this cancels out. So talk to me about 0 and -4. Is 0 smaller than -4? Is -4 bigger than 0? No. So therefore, our solutions for this one are not on the side of the line as our test point. Instead, our field of solutions are on the other side. And when we pick solutions, I'm going to go ahead and just keep it easy. I'm going to say go over 1, 2, 3, 4, over 4, up 0, over 5, up 0. Anything that you pick in this field is good. Oops, I never picked solutions here. We can pick anything we want. We'll go ahead and pick those two. Over 1, up 0, over 2, up 0. Okay. Let's do a little problem solving. Kayla wants to buy a gift for her friend's birthday. She has $45 spent and wants to get flowers and balloons. X represents the number of flowers, and Y is going to represent the number of balloons that Kayla can buy. Flowers are $15, so $15 for every X. We're going to be looking for that expression. Balloons are $2.50, so $2.50 for every Y. Which equation best represents? So 15 for X. So right away I know this one's out and that one's out. So $15 for every X, $2.50 for every Y. I have $45. Now this is what I'm spending. What if I spend more than my $45? Yeah, then I can't pay the bill, which means that this has to be because my spending, so what I spend has to be smaller than the money that I have. Okay, which combination cannot be purchased given a $45 budget? All right, grab those calculators, and we're going to go ahead and type in a bunch of these scenarios to see which works. So here's my basic equation, 15 times my value for X. So 3 flower bouquets and 2.5 times my value for Y, 5 balloons. And I want to see what that equals. Oh gosh, imagine going up to the counter and spending $57. And the lady's going to be like, no, sorry, you can't afford that. Okay, so I think we already found the one that cannot. But what I want to show you is something cool. If you go up to your calculator and hit enter, it'll recopy that line. My calculator is older, so it won't do it. All right, let's see if she can afford 2 flower bouquets plus 10 balloons. Uh-oh. Oh my gosh. Look at this. I put in 5 by accident. Let's fix that. Let's do this one again. $15 times my 3 bouquets. And then I wanted 5 balloons. Yeah, no. Can't buy it. $15. 5 balloons. Nope, can't do it. $15 times 2 flower bouquets plus 2.5 times my 10 balloons. Nope, I can't afford that one either. Alright, $15 times my 3 bouquets plus no balloons. So this one I can afford. Let's try this one. $15 times my 1 bouquet plus 2.5 for my 12 balloons. This one I can afford. Alright, last problem. Frank works at a convenience store. He earns $8.50 per hour when he works during the day. He earns $11.50 when he works at night, and he wants to earn at least. Now, an at least graph means I'm okay with working or earning more, but that's the minimum of what I want. Okay, so we're going to go ahead and see how down here it tells us our X is equal to our day hours. And do you see how here Y is equal to our night hours? When we write an equation, we have this is how much money he makes for every X, plus this is how much money he makes for every Y. And then we need to recognize that he wants to make at least $400. He's okay with making $400. That's what that line is equal to, but he'd really like to make more. So let's go back to the problem, and I have $8.50 when he works during the day, and I have $11.50 when he works at night. So right away, I know these two are not possible because this has him earning less than his $400, and I know he wants to make more than $400. All right, so here's my strategy for this. I really would like to figure out my intercepts. So if you look at this graph's intercepts and you look at this graph's intercepts, if I knew the XY intercepts of this equation, I could determine which one of these graphs is right. So just as a refresher, our intercepts, remember, are our X value when Y is equal to 0, or our Y value when X is equal to 0. So the easiest way to solve for this is to put in a 0. So for this first one, if I solve and solve for X when Y is equal to 0, this cancels out thanks to that zero product property, and I'm left with 8.5X is greater than or equal to 400. So I'll go ahead and say, okay, well, what is 400 divided by 8.5? And I know that X has to be greater than or equal to 47 point, we'll round up and call that 06. So if I look here, this has an X value of 35, and this has an X value of 46. This must be the right one. Now, I'm going to double check and do the math for my other intercept too. So I'll come over here and I'll say, okay, what is 8.5 times, what if I put 0 in for x and I solved for my y? This becomes 0. So when I take 400 on my calculator and I'm going to divide by 11.5, I get y has to be greater than or equal to 34.78. So I go back to this graph. Does this make sense that y has a value of 34? Sure it does, because it's in between 30 and 40. So this intercept checks out too. So we're going to choose C as that best answer. All right, come to class with questions. Looking forward to seeing you.